Hello everyone, I'm Esther Angelina Zhang from 10 IPAD. And right now, I'll be discussing one of the physics topics, which is the coefficient of kinetic friction. This is the table of contents. We have what is friction, types of friction, formula, and for solving problems. We are in the definition page. Friction is a force that opposes motion. Friction occurs whenever two surfaces rub against each other. For example, we have a box on the surface of the floor, and we have a force pushing the box to the right. So it makes the direction of motion of the box to the right. And remember that friction is always opposite to motion. So if the motion is going to the right, the friction is going to the left. And this is a whole figure that helps you to get a better understanding. Applications of friction in our daily life. Friction is almost all around us. For example, walking. We can only walk if we apply frictional force. Friction is what holds your shoe to the ground. Second, writing. A frictional force is created when the tip of the pen comes in contact with the surface of the paper. And third, driving vehicles on the road. Friction is the force that opposes the tire rubber from sliding on the road surface. This friction avoids skidding of vehicles. Types of friction. There are mainly two types of friction. A, friction between two solid bodies, and B, fluid friction. Friction between two solid bodies includes static friction, sliding friction, and rolling friction, while fluid friction is the friction present in liquids and gases, which are the water resistance and air resistance. So what is static friction? Static friction is the frictional force between the surfaces of two substances when they are not in motion with respect to each other. In simpler terms, static friction is the friction present in solid bodies at rest. The example is a book on top of a table. So the book doesn't fall or doesn't move. It is because there is the presence of static friction. The static friction basically holds the book to not move around. Sliding friction. Sliding friction is the resistance created by any two objects when sliding against each other. The most common example is skiing. You're sliding on a surface of the snow. This friction is also known as kinetic friction or moving friction. Third, rolling friction. The force resisting the motion of a rolling body on a surface is known as rolling friction. For example, is when you're bicycling. The friction between your bicycle wheel and road surface is called rolling friction. And this friction depends on the load, diameter of the rolling object, and surface area of the object. Now, fluid friction. Fluid friction includes water resistance and air resistance. Water resistance is a type of force that uses friction to slow things down that are moving through water. It is often called drag. The most common example is when you are swimming in a swimming pool, or maybe when you are walking in the water. You always feel a drag that is dragging you to not moving faster, and that is the water resistance. And for air resistance is a type of force that uses friction to slow things down that are moving in the air. And the most common example is parachute. Parachute using air resistance to slow down their free fall. Formula of friction. We have static friction and kinetic friction. For static friction, it is denoted by Fs equals to μs times n, wherein Fs equals to static friction, μs is the coefficient of static friction, and n is the normal force. For kinetic friction, it is denoted by Fk equals to μk times n, wherein Fk is the kinetic friction, μk is the coefficient of kinetic friction, and n is the normal force between the surfaces. So we have discussed what is friction, types of friction, and we have known its formula. And notice that we have already reached the title of the topic, which is the coefficient of kinetic friction. So we'll proceed onto the problem solving. First questions. The coefficient of kinetic friction between a block of wood and a horizontal floor is 0.25. If the block has a mass of 0.6 kilograms, what is the frictional force when the block is made to slide over the floor? Given mu equals to 0.25, m equals to 0.6 kilograms, find F. This is the block and the floor. We have weight due to the gravitational force, and we have N, normal force, which is always perpendicular to the surface. To answer, we need to remember the formula we've discussed earlier, which is F equals to mu times N. We don't have N, so we need to find the normal force. And if you look at the vertical net force, we have N minus weight equals to 0. So when we transpose weight into the right, N equals to weight. N equals to mass times the gravitational force, because mg is equals to weight. The mass is 0.6 times 10. Why we use 10? It is because the gravitational force is not given in the questions. So we use 10 instead of 9.8. 0.6 times n equals to 6. And if we already know the normal force, we will input it to the formula. F equals to mu times n. F equals to 0.25 times 6, which is equals to 1.5 newtons. So the frictional force is 1.5 newtons. Second question. A 5 kilograms box is being pulled with a force of 20 newtons and is sliding with an acceleration of 2 meters per second squared. Find the coefficient of kinetic friction. Given M equals to 5 kilograms, F equals to 20 newtons, A equals to 2 meters per second squared, find mu. This is the figure, and we have weight, normal force, and an additional of 20 newtons that is pulling the box to the right. And so here is our frictional force. To answer, we use the second law of Newton's law. Sigma F equals to mass times acceleration. So the sigma F in this figure is we have the 20 newtons and the frictional force. So 20 minus the frictional force equals mass times acceleration. 20 minus F equals to the mass 5, and the acceleration is 2. 5 times 2 equals to 10, and we transpose it to the left, so it becomes 20 minus 10, and the frictional force, we transpose it to the right, becomes positive. So 20 minus 10 equals to frictional force. The frictional force is 10. But this is just the frictional force. We need to know what is the coefficient of the friction. So if you already know the frictional force is 10, keep in mind that F equals to mu times N. Mu times N is 50. 50, maybe you're wondering why it is 50. It is because a normal force is equals to weight, just like the previous question, and weight is mass times the gravitational force. Its mass is 5 kilograms. Multiply to the gravitational force 10 makes the normal force 50. So mu times 50 equals to 10. So if we divide it all by 50, it makes mu equals to 10 divided by 50, 0.2. So the coefficient of kinetic friction is 0.2. Third question. A 50 kilograms sled is pulled along a level surface at constant velocity. It is pulled by a constant force of 200 newtons at an angle of 30 degrees. What is the coefficient of friction between the sled and the surface? Given m equals to 50 kilograms, F equals to 200 newtons, and the theta is equals to 30 degrees. Find mu. This is a figure, and we have the weight and normal force, and we have a force that is pulling the sled at an angle of 30 degrees. So there is our frictional force. To answer, we use F equals to mu times N. And we also use the Newton's second law. Sigma F equals to mass times acceleration. For the sigma F, we use F cos 30 degrees. Why? It is because if we look at the horizontal net force, it is F cos 30 degrees, not F, because we have to break down those forces into the X component and Y component. And for the horizontal, we use the X component, which is F cos 30 degrees. F cos 30 degrees minus the frictional force equals to the mass 50 times acceleration 0. Why it is 0? It is because in the question, it said that it is pulled at a constant velocity. If the velocity is constant, that means the acceleration is 0 because the velocity is constant in every time. So F is 200. 200 cos 30 degrees, and we transpose the F to the right because 50 times 0 is 0. So 200 cos 30 degrees equals to 173, and that is our frictional force. Then next we need to find the normal force. To find the normal force, we need to determine the vertical net force. We have Newton, weight, and F sin 30 degrees. The F sin 30 degrees is the force that we broke down earlier. So N plus F sin 30 degrees minus weight equals to 0. N plus 200 sin 30 degrees minus the weight 50 times 10 equals to 500 equals to 0. N plus 10 minus 500 equals to 0. And we transpose it equals to N equals to 400 Newton. And by then, if we already have our frictional force and our normal force, so then we can find the coefficient of friction using F equals to mu times N. 173 equals to mu times 400, so mu equals to 0.4. And this is our final answer. Final questions. A 0.8 kilograms Rubik's Cube is made to slide on a wooden ramp with an end raised at an angle of 15 degrees. What is the force of kinetic friction when the coefficient of kinetic friction between the Rubik's Cube and wooden ramp is 0.12? And find its acceleration. Given m equals to 0.8 kilograms, theta equals to 15 degrees, mu equals to 0.12, find F and A. And this is the figure. We have the weight and theta angle. And then we have the normal force. The normal force is not straight up because, as I've said, normal force is always perpendicular to the surface. So keep that in mind. And we have the X component of the weight, because we have to break down as the weight is either parallel to the surface or perpendicular. So we need to break it down. We have the X component and the Y component. And lastly, we have the friction. To answer, we need to find the normal force first. To find the normal force, we have to look at what's below the normal force, and it is the Y component of the weight. So N minus the y component of the weight equals to 0. N minus 8 cos 15 degrees equals to 0. Why cos? Because it is in the y-axis, and for this, it is sine. N minus 8 cos 15 degrees equals to 0. So N equals to 7.7 Newton. And frictional force equals to mu times N. The coefficient of the friction is 0.12. And the normal force is what we found, 7.7. 0.12 times 7.7 equals to 0.9 Newton. And we have answered for the A. For the B, we need to find the acceleration. We use the Newton's second law. Sigma F equals to mass times acceleration. The sigma F for the frictional force, we need to look at the force that is the same with the frictional force, and that is the x component of the weight. So x component of the weight minus the frictional force equals to mass times acceleration. The x component is 8 sine 15 degrees minus 0.9 is what we found earlier, equals to the mass 0.8 times 8. 8 sin 15 degrees is 2. So 2 minus 0.9 is equals to 0.88. 2 minus 0.9, 1.1 equals to 0.88. And if we divide it, A is equal to 1.375, but we can simply round it off, becomes A equals to 1 meter per second squared. And this is our final answer. So we have discussed everything in the table content that I showed. So thank you for listening. That's all. See you.